Hey guys, welcome to another episode of the Real Hacker Hours podcast. This is basically where I just do work on side projects relating to like volume research. I just hit the record button as I do it, and since this I didn't rehearse this or anything, this is just me actually doing the work. Probably you are going to see a lot of smooth brain mistakes. But yeah. So what I'm doing here is kind of like a follow up or just continuing the same project that I was since the last video. Just kind of for the meme of it, I'm just taking my DNS fuzzer and throwing it at a bunch of different DNS servers off of GitHub, seeing which servers it can find or get a crash from, and then going through trying to figure out exactly what the code that has the bug is and trying to patch it out and then submit a pull request to patch it out. With right here, what we have here is you have a DNS server. Let's run it and let's try to run it with Python. Oh wait, wrong port. 563. And we can see here we have what looks like to be a crash from memmove. Let's see where it's from. This is quite the stack. Gonna kill the fuzzer since we got a crash. Okay, so it's called from process request and it's memmove. Cool. I am going to look at the source code in GDB. Yeah. Actually, where is it? Here we go. DNS server. Yeah, hackery. What's the path for this again? Okay, yeah. So here it is. Process request. Here is the function. And oh, let's just. I wonder if we can just control it for a move. Because that is the function, correct? Okay. DNS server.c. Wait, 181. Copy. Okay. So it looks like from right here on the backtrace, you can see, oh, hey, it happens at line DNS server.c line 181. Look here, we can see that it's memcopy, which appears that it just replaced that memcopy with memmove. Cool. So what exactly is this bug, though? Let's see. Can I segmentate? It looks like this. So it looks like it stopped on this instruction. It appears that I'm guessing that this is an invalid memory address. Let's try and access it. Maybe not. VMAP. Six sev. Okay, let's try to figure out what exactly. 6sev. I'm gonna look up. Hang on a second. Yeah. Okay. Yeah. So yeah, we have a sexif here, which basically means we're trying to like either read or write to like a memory address that does not have those permissions assigned to it. I was able to examine that address, so which means it is mapped. However, it does not appear that it is that it is within that is readable. It has that permission. Reason why I threw up VM map is we can see the permissions here, either read, write, or executable. And let's see, can I just 1, 2, 3, 4. Okay, cool. So Trying to read. Okay, let's take a look at the source code and see if we can't figure out exactly like what's going on here. So this is the vulnerable line of code. Let's take a look at name P. What is this? Okay, so this is a char pointer equal to name. So this is a fixed stack buffer of 256. And we see that gets memcop value written there, value written there. What controls this value length, which comes from the first byte of query. Where does query come from? Query equals receive buff, which is here. Okay, cool. So looking at this, it looks like we probably control length and query. That's probably the DNS query that's coming in. Well, control query, which length is derived from query, so we control that. So I'm what I'm thinking what length specifically is what I'm thinking this function does is it reads the octet, or reads the domain name on octet by a time. That's why when it dereferences query, it is effectively okay. Let me take a step back and explain how like DNS query names are constructed. So let's say you have like something like google.com. This has, and by according to DNS standards, it has two parts. There's a Google and the com, and in the DNS RFC, it specified that the first octet or the first value for this just specifies how long it is. So Google at 1, 2, 3, 4, 5, 6 would have like a /06 specified that that length is 6. Com has 3, so you would have a 3 in front to specify that that section is 3 bytes long. So that's probably where the length is coming from. It's that value, I would assume. Now, the question here is, also, we can also see that it's being dereferenced set equal to dot, so that would also lead me to believe that, actually, never mind. The question here is, name P. So this is a pointer, it gets incremented by length, while query, okay, cool. It does not appear, there does not appear to be like a bounds out of, well, a check to see, okay, is name P overflowing? So in that case, what I'm going to go ahead and do, since it looks like we have a pretty good idea of what the bug is, I'm going to go ahead and repurpose the POC that written in the last video to effectively try and attack this, and I'm going to run it and then just try to step through and see if the assumptions that I just spent like a few minutes listing off are actually accurate. I'm going to pause the video while I do that though. See you in a few minutes. Okay, I'm back. This is the POC I ran. It's basically just a copy of the one I used in the previous video for the other DNS server. I just changed the port really. So over here, we can see that the DNS server is running, and when you run the POC, it gets a crash. Cool. Now let's actually step through and try to figure out exactly what's going on here. Process request. I'm going to disassemble. Wait, can I? Probably just break at 175. Run. Okay, it looks like that breakpoint didn't work. Okay, I'm going to delete that. Cool. Let's... Looking here, one thing that seems very obvious is we see that there's a bunch of hex OX66, which let me just double check. I believe that's F. OXFF. Nate, smooth brain mistake. Yeah, that is the little letter F, which we can see from our POC. That is the letter that should be shown a ton. So it's looking like it is an overflow, but let's just make 100% sure that it is and that it is what we think it is. Let's disable this function. Memcopy should be here. Actually, looking at this in Ghidra or like Binger or something like that would make it very obvious where this is. Or what we can do is, where is this called from? This is called from AO3. AO3 right here. This is the mem copy call that is happening. So let's set a breakpoint for this. Formation breakpoint. Okay, cool. Rerun this. Let's run the POC. Cool, we broke there. What do we see? We see okay. Okay, cool. Let's take a look. Okay, so yeah, we can see here that it is actually OXFF. Okay, so this is the destination, this is the source, and this is the length. One thing that appears very weird is for some reason this length appears to be like -1, which is OXFFFF, which is absolutely like it's a ludicrous size, which makes sense with the error that we're getting. I'm gonna just step in and finish this. Okay, this is starting to make a lot more sense. Oh, okay. So this is what I am seeing here. So what's happening is it's crashing on the first call to memcopy. Why is it doing that? Well, it's because if you look, we can tell clearly that the fact that it's crashing on a memory on when it's trying to dereference a memory address and read from it, and that it's crashing on the 6F, that the crash is occurring when it's trying to read from a memory address. Now, why is that? We look up, where is the memcopy call? Here it is. We look, wait, yeah, destination, destination, the destination RDI, source and RSI. We look at RDX register and it's literally like OXFF 8 times, so it's this massive value. So when it's trying to do the memcopy read, it's trying to legitimately read basically like all bytes mapped into memory, which there isn't. Okay, yeah. Let me think about how I want to phrase this. So it's basically trying to read an absolutely insane amount of bytes from memory and more bytes that are actually there. So it kind of has a read overflow. This is a bit interesting. I'm going to take a quick look at the source to see if I can't figure out how this value got that large. So go back to the source. Length, what is length? Length is, what is length? Length is Is it an unsigned or a signed integer? So it is a signed integer, and I believe memcopy takes unsigned. Size t. Yeah, I'm pretty sure size of t is an unsigned value. So one thing, -1 as interpreted as an unsigned value is like OXFFFFFFFF 8 times. Well, like 8 bytes of OXFF, which is an insanely large value as an unsigned integer. Let's see if we can't see how this would become potentially a -1. Length equals dereferenced query. Okay, even more so, we see that printf prints it as length as a -1. Oh, not -1. We see here it's printing the length, and over here we see that with the POC it's printing the length as -1. So one easy bug fix that I see for this, the question is, make length the variable from an unsigned integer. That would probably fix at least the first bug that we found. Question here that's also in my head is, how is it being set to -1? I think what's probably going on is when it dereferences this value, like looking at this loop, length is written to with this value, red, 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 and then it's written to here, and then, oh, completely overwritten here, and then red here. So this line of code is probably where that is being taken into account. Now, let's see if we can't find the assembly code for that, because that'll probably tell us exactly what's going on here. Excuse me, I just had a burp or something. Okay, let's look here. AO3. So this is the memcopy call. RDI, RSI, RDX. RDX. Printf. Yeah, it was stored in RDX, just making sure I'm not pulling a massive smooth brain moment. Yeah, stored in RDX. So, looking at this call right here, RDX is last written to here. Kind of, what is this? Okay, I'm probably going to be a bit quiet this next 30 seconds or so as I figure this part out. Let's see. Moved into RDX. So we have a breakpoint for there. RDX is written to here. At no other point is it written to elsewhere. and set equal to the value here as a D. That doesn't make sense though. Also, this doesn't make sense that... No. Okay, I'm starting 516 printf memcopy. Okay, I'm pretty sure the memcopy, this memcopy, isn't this one right here. I'm pretty sure it's this one right here. Reason for it being, we look at this call, we can clearly tell that printf is called immediately before memcopy. We look here in the assembly, we see a printf call right before this memcopy call that we have that is causing the bug. And if you look here, memcopy, the only function call that happens before is another memcopy call, and there appears to be a lot of stuff here. I'm pretty sure what this memcopy call was this one right here, and this assembly code in the middle is primarily this stuff right here. And also I see a conditional right here, which I see that's a conditional right here that would correspond to that. However, with this memcopy call, I'm not seeing any conditional between it and the last function call. So, conclusion, I made a mistake. This memcopy call is the one that's causing the bug and the one that we're currently looking at, which means that this RDX is set there before printf. Question, we see that it's there. Length is stored here. Why can we say that? Well, it's moved into EAX, which is moved into RDX, which holds the value, which says the last time that register is referenced in a way before the memcopy call. In addition to that, we see that, we see here that it's also referenced with this printf call, which you can see here that the length is referenced there. EXESI. Okay, cool. So what I'm going to do, I'm going to set a breakpoint for here and rerun and see exactly what happens with that instruction. Let's rerun this. RPP -0x144. That's interesting. OXFF. So somehow, looking at this OXFF, somehow the query is getting, or the length of it is being reported as FFFF. Is it 4 times? Yeah, 4 times. This is query. Where does query come from? Receive buff. Let's take a look back at the results printed. Query length 512. Count 1, Received bytes 529. Okay, but length is 1. Why is that? Where does the query come from? I'm going to copy this into another tab, that way I can just... Actually, how many times is query mentioned? 42 times. Yeah, I'm just going to copy this into another tab. That way I can just easily do Control Fs to search for stuff and know that's only in this function. Query length. Where is query first reference receive buff plus? Okay, so it's query is derived from receive buff, which is called as a function argument. Receive buff for... This is basically an infinite loop. Looks like it's pretty much just getting the contents of the query. I'm going to set a breakpoint for process request just so we can look at it. Okay, cool. Let's take a look at the receive buff. 2, 3. So let's take a quick look at our POC. We can see that it starts off, the ID is like 1, 2, 2, 3. We see 1, 2, 2, 3, 0, 0, 0, 1, 0, 0, 0, 1. Okay, it looks pretty similar to what we, at least the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 bytes appear to be basically what we had there, which will encompass all of that. The first 4 bytes. 1, 2, 3, 4. Okay, cool. Now, and we can see the last 4 bytes of this are all null bytes, so that makes sense. Now, there's FF for 255, followed by a ton of Fs, and then the second octet is there. Okay, we see it ends here. Okay, cool. So this is our total query that we are sending as a part of a POC. Could it be that since it's FF, it's somehow interpreting that as a negative number? Because... No, let's continue to the second breakpoint. Where exactly is this on the stack? 70 A1C. Let's align it. 5G. That is quite something. So it appears that it's looking in the middle of a pointer on the stack. Why is that? Let's try going. So we see. Let's take a look at the source code again. So why is it dereferencing from there? Process requests. Probably answers right here. I'm just missing it because of smooth brain mistakes. So let's get it from query. What happens to query? Query equals, oh my, size of the DNS header. Size of DNS header. So it's automatically so query is incremented here. Should move it up to DNS header. Is that a struct mentioned in here? Looks like it is. I'm going to assume that this is a static. Yeah, this probably is a static size. So it's being because DNS headers are specified by the RFC to be a static size. So this is just moving forward to the query part. Creates the position. Its name equals receive plus. Query length. What are all the points at which? So what will interferes with query? Print set query count gets that string. Let's run string length on it, but that shouldn't do anything. Query. What is the disassembly for this function again? .144. When does OX144 get written to? Gets written to here. OX138. Is there like an add? OXC. How big is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Okay, yeah, this line right here at RX12, that is most definitely this line right here. It's stored in there. Where does it get reference to? RX. This is the buffer. Cool. Okay. So why is it do? Hang on a second. Okay, so looking here, this is a copy of the assembly code from this function right here. So we know that the value being the length is stored at this right here. Before here in the function, OX144 is only referenced 3 times, and only one of those is a rate, which this value is being taken from here. So let's set a breakpoint for here and see exactly what's going on. Run it again. Cool, process request. For now, we don't care too much. RBP minus UX138. Function, cool, step. Cool, so it's the beginning of the query, which we would expect that. So we OXFF. Okay, it looks like to me what's going on is there's some weird. It's effectively just type issues is what it's looking like to me. What this problem is, because this is the side. This is the side. Yeah, it's looking like the primary issue here is just type issues. So actually, let me take a second to think how I want to phrase this. So yeah, to elaborate a bit more on what I said, what it looks like the issue, what this issue that we're looking at particularly right now is, it's trying to convert between multiple different types of data, like signed integer, unsigned integer, and a few other things like that. And it's causing that OXFF to be effectively warped into that giant OXFF 8 times, that massive integer, which is causing it. So the patch for it would be to, let's see, length. Let's change this to an unsigned integer. Unsigned int length. And let's change. No, this is a wrong data type to use. Why is it the wrong data type to use? Well, the octet is a single byte, so it should be like an unsigned byte value. Because otherwise, if it just put as unsigned integer, the length will. That's also another issue I didn't think of. Yeah, the integer value will be larger than a single octet and probably start interpreting several bytes of the actual not octet, the DNS name section as part of the length. I'm gonna go ahead and Google what like the proper what like an unsigned byte value what that exactly is. BRB. I think that's UN8. Yeah, I'm pretty sure it's UN8. Okay, yeah, I'm back. Yeah, UN8. I just replaced length with the value of UN8 and also the value it's being casted to. Let's see if this makes any difference whatsoever. Gonna delete all of these breakpoints. Okay, so that command doesn't work. Yeah, my cdev is a bit rusty. Haven't done it in a while. Okay, let's run that. Okay, cool, and then let's run this. So, this looks like it's a bit of good news. What this looks like is we have a Stack Overflow bug where you can see that it appears that there's a Stack Overflow with it since it failed the stack cookie check. This is good news since what this means is it was actually able to get through the memcopy call, meaning that there wasn't the RAID overflow, if that's an actual term, occurring in the memcopy call. So it looks like this is a separate bug on the side, but I'm going to try running this a few more times and actually set a breakpoint for that memcopy call to see if you still have that issue. Let's try it again. Okay, yeah, we can see again. It's a stack smashing. Check failed. So we had a buffer overflow. Cool. With that, let's process request. And copy. Let's set a breakpoint for here. And yeah, let's set a breakpoint for here and see if it still has that issue. Pretty sure this is the same spot. OX201. So this is clearly what the query is. You can tell that from the size and that right there. Size is OX201, which, why is that? I'm not quite sure why that's OX201 right now. What is this query? Let's hear. Why? I want to see if I can't find out why that is OX1. Set a breakpoint for here, which this is where that value appears to get written. We run the POC. Cool. We're here. I think I misread the assembly. Let's take another look at it. X144, where does that get written to? Here, it's written to right here. Sterling. Okay, pretty sure this is the wrong mem copy call. Yeah, I'm pretty sure that it is. Reason for it being is the length value is being written to directly from stir length. We see here that's what happens to query length, and then the mem copy printf calls also what happens there. It'd be so much easier if I just use something like binjo gauge or just to tell me clearly where it is. Yeah, this right here is the call that I want to look at. And we see that the size value is OXFF, which is exactly what it should be. Now, I believe there's so this right here, it's the start of a buffer that is, I believe, 256 at 256 bytes large. So when we hit this breakpoint again, it should cause a stack overflow frame that overwrites the return address, the saved return address, yeah. Nothing should happen to this. It did get overwritten. Why was that? Looking at this, it appears that... Yeah, it appears that there's a secondary mem copy call that just didn't realize it happens right there. It looks like for each iteration of this loop, it will copy 2 sections of the query name. I'm going to go ahead and set a breakpoint for this point because I believe that's where the actual overflow occurs. Should be 2 breakpoints. Cool. Let's try running it again. Okay, cool. So we are here. See our arguments. Frame. I'm first, just to make sure I'm not pulling an absolute monumental smooth brain moment, I'm going to just effectively just run this single memcopy function and ensure that the return address does not change as a direct result of the memcopy of this one. And yeah, we can see that the memcopy call there did not change the return address 868. Oh, that's the last 3 hex digits, 868. Yeah, so that's doesn't change it at all. And then we get to this memcopy call. This memcopy call, I believe it does. This one does change it. We can see here the name P is initialized to a buffer of size 256. However, that buffer gets incremented by a length which is OX 255. So this should be like right at the end of the buffer, pretty much. And this memcopy call should actually execute the buffer overflow. So let's frame. Let's step in, finish. Okay, so you can see, yeah, that memcopy call is indeed where the, let me think, where the buffer overflow does actually occur. So, in order to fix that, we will need to effectively, could we just get rid of, we could, or maybe, so we just can add a check to the length. Now, let's see, this is a void. Hang on a second. Okay, the method that I'm currently wanting to effectively remediate this is I'm going to introduce a new variable. Let's call it bytes received. And we're going to initialize this to 0. Now, what we will do is before each memcopy, we'll have a check f bytes received is greater than or equal to 256, which is the size of the buffer. Actually, bytes received plus length. Because the total bytes written after the end will be the bytes received plus the length, we will just return. And after each memcopy call, you will have bytes received plus equals length. And let's do that here. And this check should solve the problem. Okay. Let's see. Now, we recompiled the binary with that patch. Let's first see, does this actually remediate the issue? Okay, we run it, and let's try the POC. And we can see that it is not crashing it is still getting it. Let's try running the fuzzer against it. 3. So you see that it is actually still able to get queries and function effectively the server, but we are no longer able to exploit the two bugs. So it appears that this patch is working. I'm going to go ahead and submit a pull request for both the patches that we found. So just to reiterate, what bugs did we found? We found two bugs. First bug was effectively a type confusion bug, with the fact that it was using an signed integer value for what effectively should be an unsigned. By the way, in case you don't know the difference between signed and unsigned, unsigned is only from like 0 to positive numbers. Unsigned is from 0 to positive numbers. Signed numbers can just go negative. When a negative value is interpreted as an unsigned value, typically it's seen as a really large one. Go to Google if you want more specifics than that. To remediate it, we just set the length value to a uint 8, and that rectified that bug. Second bug was it didn't effectively check how much data was being written in total to a fixed sized buffer. Remediation for that is just anytime we wrote data to that fixed length buffer, we just checked, hey, will this write, in addition to the writes beforehand, extend past the end of it? And those two patches, as we can see here, rectified the problem. And yeah, I'm going to end it off here and submit the pull request to fix these two bugs. Thank you for watching, and see you guys next time.